Hello and welcome to The Explainer. Today we're diving into one of the most powerful and respected tools in the entire digital world, PostgreSQL. You know, it's the silent architect behind a ton of the apps and services we use every single day. So let's grab our digital blueprints and see what makes it. Okay, so think about it. In our digital lives, we are just swimming in an ocean of information. We're talking customer lists, product inventories, scientific measurements. It's just raw, unstructured chaos. So the big question, the fundamental challenge, is how do we take all of that messy, raw data and build something useful, something structured, something that actually makes sense? And that's exactly where PostgreSQL comes in. But I want you to try not to think of it as just a piece of software. Instead, I want you to see it as a professional toolkit. You know, the kind a data architect would use. It's this powerful open-source system designed specifically for building these really sophisticated information structures. It's how we start to build order out of all that chaos. So what does it really mean to be an architect for data? Well, it all starts with one core idea, one foundational concept that makes everything else we're going to talk about possible. At its very heart, PostgreSQL is what we call a relational database. Now, just imagine a huge library. You wouldn't just toss all the books into a giant pile on the floor, right? Of course not. You'd organize them. And that's precisely what a relational database does. It arranges data into these neat, interconnected tables, which are basically our digital bookshelves, so that finding the exact piece of information you need is fast, logical, and super efficient. All right, so every great architect has to know their building materials inside and out. And for a data architect, our materials are all the different types of information we can build with. First up, we've got numbers. We're talking integers for counting things and decimals for really precise measurements. These are the absolute bricks and mortar of our data structure. They provide that solid, quantifiable foundation for everything else we're going to build on top. Then, of course, there's text, or what we call characters. This is for things like a person's name, a product description, or an address. Back in our library analogy, this is all the text on the signs, the labels on the ends of the shelves, and of course, the titles on the books themselves. This is what gives our data context and meaning. We also really need to know when things happen. And that's where date and time types come into play. They're kind of like the official timestamp on a legal document or the checkout date stamped inside a library book. It lets us track events over time and spot important trends. Now, this is where PostgreSQL gets really, really smart, especially with modern data. It actually gives you two different ways to store complex information using something called JSON. The first type, JSON, is like saving the exact recipe for a meal word for word. It preserves every little detail of the original text. But the other type, JSON-B, that B stands for binary, is more like storing the finished meal itself. It's prepped and optimized to be served up or queried way faster. So you get a choice. Do you need the original recipe, or do you just need to get that meal out to your users quickly? Okay, so we've got our materials, we know our numbers, our text, our dates. Now we can get to the fun part and actually start designing the blueprint for our digital library. The hierarchy here is actually pretty simple, but incredibly powerful. Think of it like this. At the very top, the database itself is the entire library building. Then, inside that building, you have what are called schemas. You can think of these as different floors or wings, maybe one for fiction and another for nonfiction. And then, on each of those floors, you have tables. A table is like one single bookshelf, holding all the individual books on a very specific topic, like science fiction. But you know, a blueprint isn't quite enough. A real architect has to follow the laws of physics. Otherwise, the building's gonna collapse. Well, in PostgreSQL, our laws of physics are called constraints. These are the unbreakable rules that keep our data structure strong, reliable, and trustworthy. The very first rule, and maybe the most important, is the primary key. Its whole job is to guarantee uniqueness. Every single book in our library gets its own unique serial number, right? Well, every single row in our data table gets a primary key. This makes it literally impossible to have duplicate items, which is just fundamental for keeping your data clean. Next up, we have the foreign key. Now, if a primary key identifies a book, a foreign key is what connects it to other books. It's like the little See Also card in the old card catalogs, pointing you from a book about rocket engines to another one about space exploration. This is how we build all those meaningful relationships across our entire library. It's what makes the database relational. And then there's the not null constraint. It's beautifully simple, but it is so important. It's just a rule that says a specific piece of information cannot be left empty. For example, we can make a rule that says every single book in our library must have a title. No exceptions. This is how we stop incomplete or useless data from ever getting into our system in the first place. And look, when it comes to getting rid of data, there's a huge distinction you have to understand. Truncate is like instantly yanking all the books off a bookshelf. Poof! The data's gone, but the shelf itself, the structure, is still there, ready for new books. Drop, on the other hand, is like taking a sledgehammer to that bookshelf. Not only is the data gone, but the entire structure is demolished forever. Knowing the difference here is absolutely crucial. So, we've seen the materials, we've seen the blueprints, we've seen the rules. The big question left is, why? Why do so many architects, from tiny little startups to massive corporations, choose this specific toolkit? Well, the reasons are pretty compelling. First of all, it's completely free and open source, and it's backed by this huge, passionate global community. It's also legendary for being secure and reliable. I mean, people literally bet their entire businesses on it. Plus, it's highly customizable, so you can tweak it to fit your exact needs. All of this comes with fantastic performance, and because it follows standard SQL, it's really easy for developers to pick up and learn. It's just that rare mix of professional-grade power that's also accessible to everyone. So, there you have it. We've handed you the toolkit, the materials, and the blueprints. The rest? Well, the rest is up to your imagination. Whether you're building a simple app for a hobby or a complex enterprise system, the foundation is ready to go. You're the architect now. What will you build?